Now we will plot some graph of our trigonometric functions that we have studied so far. So first we will take sine. So this is our 0, 0 degree or 0 radians. This is pi by 2. This is pi, then 3 pi by 2, then 2 pi. And again we will have 5 pi by 2, then 3 pi, and so on. Similarly, on the negative side, we will have minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. So now we will plot the values. So sine 0 is 0. We are plotting for sine. Sine theta, and this axis denotes theta. So sine of 0 is 0. Sine of pi by 2 is 1. So let this is our y axis, and this is 1, and here it's minus 1. So pi by 2 is 1, pi is again 0, 3 pi by 2 is minus 1, and 2 pi is 0. So its graph will be like this. It goes till pi by 2, then comes back to 0, then goes to minus 1, and then again to 0. And any value here will be repetition of this part. 0 to 2 pi. Because if I add any, so I said here that if we have a point P here at an angle theta, and if I add one complete revolution to this theta, that is theta plus 2 pi, then we will reach at the same theta. So any value of theta after 2 pi, so 2 pi is same as 0, and this will be equivalent to pi by 2. So again here it will reach 1, and again come 0, back 0, and similarly on the negative side. So minus pi by 2, we can add 2 pi to minus pi by 2, and we will get 3 pi by 2. And we add 2 pi to minus pi, we get plus pi, so 0, and here we will get pi by 2, so it will be 1, and if we add 2 pi here we get 0. So on both sides this will repeat infinitely. That's why any value of theta we take, sine theta is defined, and it takes values between 0 and 1, sorry, minus 1 and plus 1. So now we'll draw a graph for cos theta. So for cos theta, at 0 it's plus 1, at pi by 2 it's 0, at pi it's minus 1, at 3 pi by 2 it's 0, and at 2 pi again it's 1. So its graph is so its graph is also similar to sine. The only difference is that it's shifted. It's shifted by pi by 2. So this part, the value that was coming at pi by 2, it's coming at 0. The value that was coming at pi is coming at pi by 2. So this whole graph is shifted by pi by 2. But the nature of graph is same. So again here cos is also defined for all the values of theta, because this series sequence will repeat itself, and it also takes values between plus 1 and minus 1. And now we will draw the graph for tan theta. So while defining tan theta, we had given this condition that for all the odd multiples of pi divided by 2, it will be infinite. So for 0, tan theta is 0. For pi by 4, we had seen that both sine and cos are same. So at pi by 4, it's 1. For 60 degree, that is pi by 3, it was root 3. Root 3 is 1.732, so it will be here. For pi by 2, it will be sine is 1, cos is 0. So it goes towards positive infinity. So it increases like this and becomes close to infinity at pi by 2. It's not defined at pi by 2. And if it's more than pi by 2, we reach the second quadrant here. In that case, sine is positive and cos is negative. But for a value very close to 90 degree, so just greater than 90 degree here, sine is almost 1, maybe 0.9999999, for value just greater than pi by 2. And for the value just greater than pi by 2, cos is approximately 0, but negative 0, minus 0.000001. So sine is positive, cos is negative, but the values are same, 1 and 0. So it will be approximately minus infinity. 1 divided by minus 0, minus 0.00 something. And at pi, it will be 0. Its graph is like this only. So here it's plus infinity, and here it goes towards minus infinity, and at pi again it's 0. At 3 pi by 2, 3 pi by 2 sine is minus 1 and cos is 0. So for just before this, cos is some negative quantity close to 0, so it's minus 0.0000 something, and sine is minus 0.999999, so both are negative. So again it will be plus infinity, so minus 1 divided by minus 0, and here it will be equal to 1 at a difference of pi by 4 from pi and 3 pi by 2 both, and again here it will be minus negative infinity, and at 2 pi it will be 0. And now again this all these values will repeat itself at intervals of 2 pi. Here it's repeating for 0 to pi only, it repeats after 0 to pi, because tan theta becomes positive after pi, and on the negative side also this will be like this. So this is the graph of tan theta. So we see that it's not defined for all the values of theta, unlike sine and cosine. So it's defined for all the values of theta except these pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, these values. But its range is now very large. It can take values from minus infinity passing from 0 up to plus infinity. So it can take all the possible values. So any value we take, we can get a theta corresponding to that for tan theta. And now we will plot for cot theta. So here for cot theta it's cos theta divided by sine theta. So at pi by 2 cos is 0, sine is 1. So here it will be 0. And at a value just more than this, sine is 0. So denominator is 0. So it will be positive infinity. And at pi it will be minus infinity. and here again. So this cot theta also looks similar to tan theta, but it looks like just the mirror image. So the curve just looks like the mirror image. If we flip it about a vertical axis, so we switch its left and right parts, we get this curve. And also it's shifted by pi by 2, like we had seen for sine and cos. So it was at 0 it is plus infinity, and here it's plus infinity at pi by 2. So we have seen the graphs of main functions. Now we can define our domain and range for these functions. So quickly we will define domain and range. So first sine, for sine x, then cos x, then tan x, cosine x, sec x, and cot x. Now we will see the domain and range of these functions. So first I will write domain, and then I will write range. So for sine or domain, that is the values of x for which sine x is defined. So it's defined for all the values of real numbers. Similarly for cos, and its range was between -1. It can only take values between -1 and +1. So its range is from -1 to +1. Similarly for r, range is from -1 to +1. For tan, we have seen that it's defined for all values of r except these pi by 2, 3 pi by 2, and so on. So here it's r minus 2n plus 1 divided by 2 pi, because cos theta was in the denominator and cos theta is 0 for all these values of theta. And similarly for sec, we will have cos in the denominator, so again we will have the same value, 2n plus 1 divided by 2 pi. But tan theta takes all the values, so its domain is r. And now for cosine theta, it's 1 upon sine theta. So sine theta is not defined. Sine theta is 0 at 0, pi, 2 pi, 3 pi, all the multiples of pi. So it's r minus n pi, where n is where n belongs to. So here for wherever we are using n, we will assume that n belongs to the set of integers. So it can take values of 0, +1, -1, +2, -2, and so on. So it's defined for r minus n pi, and similarly cot, because in the cot also sine comes in denominator. Now cot also takes all the values of r, as we have seen in this graph. So it takes values from minus infinity to plus infinity. Now for sec and cosine, the maximum value that sine can take is from the maximum value that sine can take is 1. So the minimum value, so cosine can take value 1 when sine is 1, but when it's from 0 to 1, so if its sine is close to 0, close to positive 0, cosine will be close to positive infinity. So if we draw cosine here, so at plus infinity 0, cosine will be here plus infinity. At 1, it will be 1. Then again here it's just before pi, it will be positive infinity. So here I am drawing the graph of cosine, and here the value becomes negative, so cosine also becomes negative. So at pi it will be negative infinity. At 3 pi by 2 it will be exactly minus 1, and at 2 pi again it will be minus infinity. So this cosine value comes from in plus infinity, comes till plus 1, then again goes to plus infinity, and on the negative side it moves from minus infinity till minus 1 and then goes back to minus infinity. So within this range, minus 1 to 1, it's not at all defined. It cannot, it's defined, it cannot take any value between minus 1 and 1. It will take the value minus 1 and 1, but not any value greater than minus 1 or any value less than 1. So for cosine, the range is from minus infinity to minus 1. So here minus 1 is included, union from plus 1, here plus 1 is included till minus infinity, till plus infinity. So we can also, so this will be the same for secec also, and this we can also write it as r minus minus 1 to 1. So from real numbers we exclude this range from minus 1 to 1, then we will get this value. So these are the dominant range of our main trigonometric functions. Now quickly I will take one numerical example. So example says if cos x equal to minus 3 upon 5, where x lies in the third quadrant. So x takes the values more than pi and less than 3 pi. Find the values of other trigonometric functions. So x lies in this quadrant and its value is minus 3 pi by 2. So in this quadrant, sine will be negative. So sine is negative, cos is negative, and we are getting a negative value as expected. But cos is negative in this quadrant also. So if we are just given cos theta is minus 3 upon 5, then we cannot uniquely find all the other trigonometric functions because cos is negative in second quadrant also and third quadrant also. So based on that we will get multiple answers. But if we are told that it lies in third quadrant, we will get a unique answer. So sine will be 1 minus cos square because sine square plus cos square is 1. Or x, it's x written here. One minus 9 upon 25 and 25, so we will get under root of 16 upon 25, that will be equal to plus minus 4 upon 5, because under root of any quantity is both plus and minus, but we are told it's third quadrant, and in third quadrant sign is negative. If it was told second quadrant, we would have taken the positive sign, but it's third quadrant, so we will pick the negative sign. So since it's third quadrant, we will write minus 4 upon 5 because it cannot take plus 4 upon 5 in the third quadrant. So this is sine theta, sine x. So cosec x would be the inverse of this, reciprocal of this. Inverse is different thing. So it will be 1 upon sine x, which is minus 5 upon 4. So we have to find the remaining 5. So 1 we have found, this is second. Now cos we know, so sec x would be 1 upon cos x, and cos is minus 3 upon 5, so it will be minus 5 upon 3. So this is our third one. Now we need tan. Tan equal to sine upon cos. Sine is minus 4 upon 5, cos is minus 3 upon 5, so it will be 4 upon 3. And cot x is equal to 1 upon tan x, so 3 upon 4. So if we are given one of the trigonometric functions, sine or cos, tan would not do, because if we are told that tan is 4 by 3, then it can have multiple values of sine and cos for the same tan x. But if we are given either sine or cosine or sec or cosec, any of these four, then we can find the remaining functions. And we also need to know the quadrant, because all the trigonometric functions are negative in two quadrants and positive in two quadrants. So we need the quadrant information also. So I will take one last example. So we are told to find the value of sine, say minus uh, minus 540 suppose, or 450. Let minus 450 degrees. So clearly this is absolute value of this is more than 360 degree or 2 pi. So we can always add 360 degrees, keep adding 360 degrees till we reach in our range between minus 2 pi to plus 2 pi, or so minus 450 degree is equal to sine minus 450 degree plus 360 degree is equal to sine minus 90 degrees. So minus 90 degrees same as 270 degree, because if we add 360 here we will get 270. So positive angle is in this anti-clockwise direction, and if we move in this direction we get negative angle. So minus 90 would be this value here. So this is same as plus 270. So here we had seen the value of sine at this is minus 1. So at 3 pi by 2 sine theta is minus 1. And we could have also written here minus sine 90 degree. So one important property which we can derive if we just write down the ratios of sine and cos from our first picture here. So if we take minus theta and this point is P prime, so this value, this is exactly minus theta. So this A will remain same, but B will become minus B. So here sine theta will become negative and cos theta will remain same because A is same, A upon R is same. But here for sine theta we will get minus B upon R. So sine minus theta is equal to minus sine theta, because sine theta will become negative here for negative theta, but the value of cos theta still remains same here. So we could have written this is minus theta, our new angle. So this is equal to, this value is minus B now, so it becomes minus B upon R, and B upon R is sine theta, so this becomes minus sine theta, and this remains as A by R, and A by R is equal to cos theta. So cos minus theta is equal to cos theta, but sine minus theta is equal to minus sine theta. So this thing we should remember, it will be very useful. Sine minus theta is equal to minus of sine theta and cos minus theta is equal to cos theta. Try this same experiment with other trigonometric functions by yourself, and that would give you some practice whether the sign of function changes or not. And also we see that for any trigonometric functions it's same as if we write 2n pi, if we add any multiple of 2 pi, then this value remains unchanged. So these are some small tricks which come in handy while solving the problem. So like here we could have directly written minus sine 90 instead of visualizing that minus 90 is this 270 degrees. So its value is minus 1. So that's all for this lecture. With this we will end this, and in next lecture we will see some more properties of trigonometric functions and solve other problems. So thanks for watching.